Hey there guys, Paul here from theengineeringmindset.com. In this video, we are going to be looking at how electricity works. Now this is pretty essential knowledge for any engineer, so we'll run through the basic parts of what you need to know. So let's start at the very basics, and for that we need to take a look at the atom. Everything, including you, is made from atoms. All the materials we use are made from atoms. The materials are just different because the construction of their atoms are slightly different. The atoms are made from three particles, two of which are found inside the nucleus, and the third particle sits outside this. At the center of the atom we have the nucleus. Inside the nucleus we have the neutrons, which have no charge, and we also have the protons, which are positively charged. The neutrons and the protons are much heavier than the electrons, so these will stay within the nucleus. Surrounding the nucleus are different layers of orbital shells. These are like flight paths for the electrons. The electrons flow along these flight paths much like a satellite orbits our planet, except that the electrons travel at almost the speed of light. The electrons are negatively charged and they are attracted to the positive charge of the protons. The electrons orbit around the nucleus in these orbital shells, and there are a set number of how many electrons can be in any one orbital shell. The number of protons, neutrons and electron an atom has tells us which material it is. Atoms hold on to their electrons very tightly, but some materials will hold on to them more tightly than others. The outermost shell is known as the valence shell, and in this shell some materials have loosely bound electrons which can flow to other atoms. Atoms which can pass electrons are called conductors, and most metals are conductors. On the other hand, atoms which do not have free electrons and so they can't pass electrons between other atoms are known as insulators, and these are things like glass and rubber. Now we can combine these materials to safely use electricity by having the conductor in the center, which allows the electrons to move, but surround this with an insulator to restrict where they can flow to, i.e. not into us, which keeps us safe. If we look inside a slice of copper cable at the free electrons surrounding the nucleus of the copper atom, you'll see that the free electrons are able to move to other atoms, but this happens randomly in any direction. If we then connect the slice of copper cable to a closed circuit with a power source, such as a battery, then the voltage will force the electrons to move, and these will then all flow in the same direction to try and get back to the other terminal of the battery. When I say circuit, this just means the route which electrons can flow along between the two terminals, the positive and the negative, of a power source. So we can add things into their path like light bulbs, and this means that the electrons will have to pass through this in order to get to the other terminal. And so we can use this to create things such as light. The circuit can even be open or closed. In a closed circuit, that means the electrons can flow around, and in an open circuit, this means that the electrons are not able to flow. Voltage is a pushing force of electrons within a circuit. It's like pressure in a water pipe. The more pressure you have, the more water can flow. The more voltage you have, the more electrons can flow. But what does a volt mean? Well, a volt is a joule per coulomb. And a joule is a measurement of energy or work, and a coulomb is a group of flowing electrons. We'll have a look at what a coulomb is in just a second though. So a 9-volt battery can provide 9 joules of energy in the form of work or heat per group of electrons that flow from one side of the battery to the other. In this case, the current of electrons flow from one side of the battery through the LED light bulb, which produces light, and then the electrons flow to the other side of the battery. Therefore, 9 joules of light and heat is produced by the light bulb. Current is the flow of electrons. When a circuit is closed, it means electrons can flow, and when the circuit is open, no electrons will flow. We can measure the flow of electrons just like you can measure the flow of water through a pipe. To measure the flow of electrons, we use the unit of amp. 1 amp means 1 coulomb per second, and 1 coulomb is a group of electrons. The group is incredibly large and is approximately 6,242,000,000,000,000,000 electrons, and that has to pass in 1 second for it to equal 1 amp. That's why electrons are grouped together and just called amps to make it easier for engineers. Resistance is a restriction to the flow of electrons in a circuit. The wire which carries the electrons will naturally have some resistance. The longer the wire, the greater the resistance. The thicker the wire, the lower the resistance. The resistance to the flow of electrons is different for each material, and the temperature of the material can also change the resistance to the flow of electrons. Electrical circuits use specially designed components known as resistors to purposely restrict the flow of electrons. This is either to protect other components from too many electrons flowing through it, or it can also be used to create light and heat, such as in an incandescent light bulb. Resistance occurs when electrons collide with atoms. The amount of collisions is different from one material to another. Copper has a very low collision rate, but other materials such as iron will have much more collisions. When collisions occur, the atoms generate heat, and at a certain temperature the material will then start to produce light as well as heat, which is how the incandescent lamps work. When a wire is wrapped in a coil, it will generate a magnetic field as the current passes through it. The cable will naturally create an electromagnetic field by itself, it's just intensified by the coil. By wrapping it in a coil, the magnetic field becomes so strong that the magnetic field starts to actually affect the electrons within the wire. But we'll look at why this occurs in a future, more advanced video. We can increase the strength of the magnetic field simply by wrapping the coils around an iron core. We can also increase the number of turns within the coils, and also we can increase the amount of current passing through the circuit. Now this is how electromagnets work, and it's also the basis of how induction motors work. If you want to learn more about induction motors, we've already covered this in another video already, just see the link on screen now. Now when a magnetic field passes across a coil of wire, it will induce a voltage in that wire caused by an induced electromotive force which is pushing the electrons in a certain direction. If the wire is connected in a circuit, then this electromotive force will cause a current to flow. This is the basis of how AC generators work, and the electricity at your wall sockets within your home is produced in a very similar way. Transformer. Now we can combine all of the aspects together that we've just covered, and when we do so we'll see that we can use one coil to generate electricity, and then we can place two other coils in very close proximity to each other but not touching, and this will create a transformer. The transformer will induce a voltage from the first or the primary coil over into the secondary coil, and this will force electrons to flow if the coil in the secondary side has a closed circuit. Now what's important about the transformer is that we can increase or decrease the voltage between the primary and the secondary coils simply by changing the amount of coils on either side. Again, this is a subject all by itself, so we'll cover this in a more advanced video later on. Now something else which I just want to briefly mention is the capacitor. So a capacitor forces positive and negative charges to separate across two plates when it is connected to a power supply. This causes a build-up or store of electrons within an electric field. When the power supply is cut or interrupted, these charges will then be released, flow up and meet again. This provides a power source, but only for a few seconds until the charges have paired back up again. It's slightly similar to a battery, but capacitors are very common and they're in almost every single circuit board. We'll cover this obviously in more detail in a future video, just be aware of these. So the last part I want to cover in this video is that there are two types of current electricity, that being alternating current or AC, and then direct current or DC. Alternating current simply means that the current flows backwards and forwards in a circuit as the terminals are constantly reversed. This is a bit like the tide of the sea. It goes in and out, in and out, in and out, so that it's reversing constantly. Now alternating current is the most common source of power, and the plug sockets in your homes and your buildings and schools and workplace, etc. These will all be providing alternating current, AC. Now on the other hand, we've got direct current or DC, and that simply means that the current flows directly in only one direction. It does not alternate. This is what's provided from batteries, and almost all your handheld devices are from this as well. So we can convert AC to DC and vice versa using power electronics. And this is how we charge and power small devices. And it's also how solar panels can be used to power our homes, because solar panels produce DC power and our homes need AC power. So we have to convert this for it to be usable. So both AC and DC have pros and cons to it, but for sure we'll look at this in another later video. It's a bit more advanced. And there's also quite an interesting history behind why we use AC and DC and the inventors behind that. If you've got 10 minutes, I definitely recommend having a Google or a YouTube of this too. Alright, that's it for this video. Thank you very much for watching. I hope you enjoyed this and it helped you. If you have any questions, please leave me in the comment section below. Also, don't forget to subscribe and check out our website, theengineeringmindset.com.